Hello and welcome to today's maths lesson. My name is Robert and it's great to be here. It's great to be able to do this and just to be able to bring learning to you. Today in our maths lesson we're going to be talking about analytical geometry, and like we discovered in the first lessons, analytical geometry is the link in maths between algebra and geometry. It's a way to solve algebraic problems geometrically and geometric problems algebraically. We've spoken about tangents, we've spoken about points and angles and so on, and today we're going to be talking about circles. So let's get to that. In functions over the years, we've learned that certain equations represent certain graphs. So if I put this graph up on the board, y equals x squared, can everyone remember what that equation represents, what graph that equation represents? Well, if you guys remember, y equals x squared represents a parabola. And in this case, it's a happy face, but it could also be a sad face if it was a negative x squared. The next equation, y equals 2x plus 3, we've discussed these in these lessons. This is, can you guys remember what this is? This is a straight line where 2 is the gradient and 3 is the y-cut. If we look at the next one, y equals 2 over x. If you guys can remember what this is a hyperbola, and that's what my hyperbola looks like. And so in functions, every different equation represents a different type of curve. And this, x squared plus y squared equals 4, this is new. And this is what we're going to be talking about today. This represents a circle. And so x squared plus y squared equals 4 represents a circle. If I ever see an equation in that form, I know that that is a circle. Now, exactly like with the straight line, y equals 2x plus 3, 2 represented the gradient and 3 represented the y-cut. In a hyperbola, that 2 at the top there, that represents the shape of my hyperbola. When we're talking about a circle, every little bit also represents something to do with that circle particularly. So if we look at the standard form of a circle, x squared plus y squared is equal to r squared, that r is always going to be the radius of my circle. So here I can see my circle, here I can see that my radius is drawn in there, and the length of that radius is always going to come into my equation in the answer, r squared. We're going to be moving our circles later on in the lesson, but for now, the circle is always going to be centered right there at the origin, which has the coordinates 0 and 0. Okay? Wonderful. So let's do an example. We're going to be drawing the circle x squared plus y squared is equal to 9. Now, all I need to know to draw a circle is what is the radius? So how big must I make the circle? And where must I place it? What is the center of the circle? Now, like we've discussed, the center for this, and we're going to be moving it a little bit later on in the lesson, but the center for this is going to be at the origin. The center is going to be placed at 0, 0, right in the middle of my Cartesian plane. The radius, well, what did we decide? We decided that the form our circle is going to come in is going to be x squared plus y squared is equal to r squared. So that 9 is my radius squared. So how do I work backwards? If 9 is my radius squared, how do I work backwards to get my radius? Well, what I'm going to do is I'm going to square root 9, and what I'm going to get is 3. And so I could have written this equation, let me erase this a little bit. I could have written my equation as x squared plus y squared is equal to 3 squared. Because in this case, my radius is 3, while 9 is 3 squared. And therefore, I have my radius, I have my center, and I can go and draw my circle. Here, I've drawn my circle. You can see my circle is placed right there. The center is at the center of my Cartesian plane, the origin. I can see that that distance there, well, this is going to be 1, this is going to be 2, this is going to be 3, and so my radius is 3 units from the origin, and the same here. This is 1, this is 2, this is 3, this is -1, this is -2, this is -3. And so we can see here I've drawn my circle with a radius of 3 centered at the origin. Great. We're going to be going to an ad break now, and then we're going to do some examples. So we'll see you guys soon.